Okay, so this is the implementation of a novel optimizer. So which is based on three different concepts. One is nested learning, another is golden triplet, and the other is selective memory synchronization. And it is implemented with a LoRa Plus architecture using the Google Tunix. So basically, let me quickly go to the optimizer architecture. So for this, I will show the architecture. So what happens in this is basically we can see it has multiple memory states where it stores different memory states. It has three different waves. One is high frequency gamma wave, another is the mid frequency beta wave, another is the low frequency alpha wave. So basically all of these are implemented in hierarchical manner, and basically the output from the gamma wave is accumulated in a memory state for subsequent delta beta timestamps, which is 5 in this case. So after 5 iterations, this accumulated memory is then updated as the beta wave update. And then similarly, hierarchically, it follows the same principles. And this update logic, update equation is it follows the Adam update equation, which is basically 1 minus beta times the momentum of beta plus beta by delta beta I'm doing to give the mean accumulation and then multiplies the accumulation. So basically you can say beta is the learning rate for the beta wave. And now this aim of beta, which is the beta wave which is accumulated for the update of the alpha waves, which will then get accumulated for 13 steps, and then it would get updated. And the final update which is created is mu is the learning rate here, and mu times m of the gamma wave, which is the fast high frequency wave, divided by the square root of the low frequency wave, both of these low frequency wave. So this is how the update occurs, and this is the final update. And this is the nested synchronization and nested learning architecture. And along with this I have also from the golden triplet rule, the paper suggests that in brains the waves, they are kind of factored. They are not just discrete waves, they are factored in a factorization of the golden ratio. So that's why what I have done is basically the gamma wave. Another thing here is that the gamma wave is generated or is predicted, you can say, from an internal multilayer perceptron, which is optimized by its own Adam optimizer. And this Adam optimizer, it takes the initial states, different states, so from different waves. So basically the gamma state, then the accumulation from the alpha and the beta waves, and then finally it determines. So the idea behind this is basically it would understand how much information has been accumulated and how much is to be pushed to the gamma wave. So that's why the learning rate for the gamma, the output is kind of adaptive, which is predicted by the multilayer perceptron. And then beta is directly a factorization of it's a factorization of the golden ratio. So here you can see that here you can see if I zoom in, you can see that beta equal to gamma by 5, which is the golden ratio. And then alpha is beta by 5, which is again a factor of golden ratio. So this is how the alpha beta are determined. So ultimately all of these alpha beta depends on the gamma, and the gamma is obtained from the multilayer perceptron. So this is one part of the optimizer. The second part is basically, this is the nested learning part of the optimizer. The second part is basically the Yeah, so it's basically the synchronous memory update. So what happens here? Another paper I have referenced the papers in the documentation. You can go through them. So it suggests that what happens in which way, how we can store information of long term is basically we store these informations, and all these informations are collated during our sleep. So whenever we experience something or we gain some knowledge, certain receptors in the brain are activated, and it not only stores the experience, but also it stores all the memorable things that have happened, and all the significant things that have happened. And then what it does is it consolidates all of these informations and keep the most relevant informations during our REM sleep, which is rapid eye movement sleep. So during that time, so to mimic that part, I have introduced this particular block, this learning sync block. What it does is basically it takes input from I mean it basically it calculates a score which is derived from the ideal logic would be to calculate these scores from the feedback mechanism, because the feedback or the RL feedback or the scoring that we are giving after the model, after performing a correct output, after giving the correct output, we are giving the RL feedback score. That would be a better idea. But since in Tunix I couldn't find any particular way to connect these scores and to transfer these scores into the optimizer, so that's why what I have done is basically use the gradients for that. So what I'm doing is calculating the difference of the previous gradient to the current gradient. And then what I'm doing is basically scaling this with the previous gradient. So what happens is that whenever a good experience happens, there is a little bit of correction here. So I have updated that in the document. It is basically g t minus 1 minus of gt. It would be opposite of this. So anyways, so what happens is that whenever g t minus 1 is greater, it means that the previous gradient was greater and the current gradient is smaller, which means the previous update was a better update, which was a good update. And then when we are scaling it with g t minus 1, what happens is that basically it scales up the good updates, because now g t minus 1 is also smaller than the gt. So that's why it scales up. So what happens is that whenever a good update has happened in the previous state, which has led to a lesser gradient in the current step, it would amplify that particular update, and it would store in the accumulation state. So a theta state it would store here. And now after tau interval, which is basically 100 steps, which I have kept in this experiment as 100 steps, what happens is that this gets updated. So you can see that a of tau is created for every step. A of tau is created, and it gets updated and stored in the a of theta state. And after this 100 sync intervals, for every interval it does update this with this formula. So it is also like a similar kind of knowledge gain formula, which is used for other waves, alpha beta gamma wave, and also for it's also referred from the Adam optimizer. You can go deep dive into the mathematics. And then what happens is that this alpha theta t, which is accumulation of all the good updates, they get implemented into the final updates at the taueth interval, which is the 100th interval, or multiple of 100 interval. So every 100 interval, this would get updated to the updates. So this is basically what this entire optimizer does. And it has done a comparatively good job in math olympiad questions, which are very difficult. So here you can see the output results of this. So basically the correct answer increased by a relative percentage of 80%. It was earlier 20% with the base model, which is 36 now, and also the accuracy also improved by 8%. format accuracy improved by 120%. So these are all the relative improvements, but these are significant improvements since I have only trained this for very with a very small amount of parameters, only like 25 million parameters, which is comparatively very small respect to the entire 1 billion parameter model, only 2.4% of it. And also I have trained it only with a rank of 32, and a training data set size of 1500. So that's also another thing that has that is also constant. So that's why now it can solve, and these are all scores based on math olympiad questions, which are quite difficult in nature. So the current optimizer was able to perform quite well in this particular case, and increasing the rank and also the training data side was significantly improved. Also, one of the main constraint what I faced is that for complex problem solving, a 728 output token was very limited, because often it would get exhausted for multi-step long answers. That's one thing that I faced a problem. So this increasing this would also increase the accuracy to a huge extent. So that's also another thing that can help. So yeah, so this is the overall implementation of the nested multi-frequency adaptive optimizer with selective memory synchronization.